Have you ever wondered what happens when we burn waste? Incineration has been a common method of waste treatment for many years. However, rising concerns have made this method less acceptable. Let's explore why waste incineration and its emissions are being critically evaluated. Municipal waste incineration generates energy by burning waste materials. Unfortunately, it also produces harmful emissions. During the incineration process, two byproducts are produced: solid ash and flue gas emissions. On a mass equilibrium basis, the raw stack emissions will be directly inverse to the volume of ash generated. If you input 100 ton of waste, you must get 100 ton of byproducts output. For instance, burning 100 tons of waste yields 25 tons of ash and 75 tons of flue gases. To achieve complete combustion, continuous oxygen supply is needed. Pulling ambient air into the incinerator chamber can meet this need. However, as the oxygen content of the ambient air is only approximately 23% by weight, then an additional volume of air is required to fulfill the complete combustion needs. Since nitrogen makes up about 78% by volume of ambient air, the combustion chamber is flooded with nitrogen, leading to the formation of harmful byproducts like NOx. For every ton of carbon waste burned, about 2.67 tons of oxygen are required. Therefore, a minimum of around 11.61 tons of ambient air must be introduced. Here's how it breaks down. 11.61 tons of ambient air, multiplied by the percentage of oxygen in ambient air, which is 23%, gives us the necessary 2.67 tons of oxygen. Additional air flow is required to ensure complete combustion. The total amount of flue gas produced is the sum of the mass of ambient air plus the mass of carbon fuel waste. So burning 1 ton of carbon fuel waste needs 11.61 tons of ambient air. This results in a total of around 12.61 tons of flue gas being generated, which can increase to approximately 13 tons due to airflow needs. Notably, flue gases contain 15% to 18% carbon dioxide. The incineration of 1 ton of carbon waste generates 13 tons of flue gas emissions. Now, let's discuss incinerator ash. When waste is burned, two primary byproducts are created: incinerator bottom ash, IBA, and fly ash. Fly ash is a fine particulate collected from flue gases, while bottom ash is the solid fraction that falls to the furnace's bottom. The bottom ash can be processed to eliminate contaminants. This results in clean circular aggregate material for construction industries. The purification process also allows for the extraction of residual metals, including precious and rare earth metals, making waste management more sustainable. Today, many locations still use waste as fuel for heat and electricity. However, due to environmental sustainability, the establishment of incineration projects has drastically decreased. As technology advances, new bioenergy harvesting methods emerge. We are moving towards a greener future through biorefining and thermal reduction techniques, focusing on emissions control and byproduct valorization. In conclusion, while incineration of waste generates significant byproducts and emissions, new technologies may help mitigate its impact. Understanding these complexities allows us to find better solutions for waste management. If you'd like to learn more about innovative waste management solutions, visit our website waste.net.